Hello viewers, I am Kausalya. Today we are going to solve problem 3 and 4 in exercise 13.3. Problem number 3. A 20-meter deep well with diameter 7 meter is dug and the earth from digging is evenly spread out to form a platform 22 meter by 14 meter. Find the height of the platform. So here in this problem, the shapes are not given directly. You see here a 20-meter deep well, right, with diameter 7 meter. So it has a diameter. What do you mean by 20-meter deep? Here the word deep represents the height or length, right? So obviously this is a cylinder. So whose diameter is 7 meter and whose length is 20 meter. Now, the earth from digging is evenly spread out. That is, while making this well, okay, we will be removing the soil like this, right, from the earth. So, that earth or soil is evenly spread out to form a platform. Okay, here they had simply mentioned the word platform, whose dimensions are 22 meter by 14 meter. Now, find the height of the platform. So here you see what is the shape whose dimensions have 3 parameters. Obviously it is a cuboid, right? So cuboid or cube, anything. But here since you see the parameters vary, we are telling it as a cuboid. So here the platform is in the shape of a cuboid whose length and breadth are given and we have to find the height. So here since we need to find the height h, right, and the other two parameters are length and breadth. So obviously we are fixing the platform, the unknown shape as cuboid, right. Just from the problem you have to make a clear observation. That's it. So this cylinder is transformed into a cuboid whose length is 22 meter, breadth is 14 and height h we need to find. So just write down the given parameters. First we start with cylinder. Here the radius r is, the given parameter is diameter. Therefore 7 by 2 is the radius and height h is 20 meter. And here in this cuboid length and breadth are given. We need to find the height. So volume of the cylinder is equal to the volume of this cuboid because the soil which is removed from this pot is transformed into a cuboid here. Therefore, volume of the well is equal to volume of the platform. In other words, volume of the cylinder is equal to volume of the cuboid. So, what is the formula for cylinder? It is pi r square h and volume of cuboid is L into B into h. Since here we are having two heights, I am mentioning this one as h1 and this as h2. If you want, you can just write it clearly, right? Let h1 be the height of the cylinder and h2 be the height of the cuboid. Now just substitute the values. For cylinder, we know all the parameters r and h. So just substitute it here. And L and B we know in cuboid. So again substitute the value. Now we need to find H2. So here I am just moving these extra terms. Okay, initially I am cancelling the common terms. Then I am having 11 into 7 into 10 which is equal to 22 into 14. Since I need to find H2, I am bringing this 22 into 14 to the left hand side. Here they are in the numerator part, so I am moving this to the denominator. So here comes 22 into 14. Again when you cancel out the common terms, finally the value of H2 is 5 by 2 which is 2.5 meters. Therefore, the height of the platform is 2.5 meter. Here comes the end of this problem. We will proceed with our next one. Problem number 4. A well of diameter 3 meter is dug 14 meter deep. The earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meter to form an embankment. Find the height of the embankment. So here we have a well whose diameter and dug 14 meter deep. Again here the word deep refers the height. So well is in the form of a cylinder, right? It has a diameter of 3 meter and a height of 14 meter. Now the earth taken out, it has been spread evenly all around it. That is, this is the well, okay? This is the well, and the earth, that is the soil which is removed from this space, okay, from the well, is evenly spread around it, right? The soil taken from the well is spread around the well in such a way that they form an embankment. Now the width is given, right? So this is the width of the embankment and we have to find the height. So this is the diagram, okay? This is your well, okay? The thing which I had drawn in black color is well, and this part is the embankment. The soil which is taken from the earth is spread evenly around the well. Now the width is given. The width is 4 meter. We have to find this height. So here we are prioritizing as let h1 be the height of the well and let h2 be the height of the embankment. Similarly, r1 is the radius of the well and r2 is the radius of the embankment. Now again when you look at this diagram, you see the well is in the form of a cylinder, and similarly this embankment is also in the shape of a cylinder. So now we are writing down the parameters. You see the diameter of the well is 3, therefore the radius is 3 by 2 and height is 14 meter. Now the next is we are going to write the parameters of the embankment. So here the width of the ring, okay, this is the well and this is the soil where it is placed and the width is 4 meter. So width of the ring is 4 meter. Here we need to find the height h2, which is nothing but height of the embankment. Now we will start our solution by writing volume of the well. Again you see this volume of the well should be equal to the volume of the embankment because the earth, that is the soil which is taken out from this part, is evenly spread around it. So obviously volume of the well is equal to the volume of the cylinder. So volume of the well is given by the formula pi r square h. Since here we are discussing with two cylinders because well is one cylinder and this embankment is also a cylinder. Here I am writing R1 H1 as parameters of well and R2 H2 as parameters of embankment. So here the value of R1 is 3 by 2. So just substitute it, and the value of H1 is 14. Again when you cancel the common terms, finally we are ending up with 63 pi by 2. So this is the volume of the well. Again you have to write the unit meter cube. So name it as equation 1. Now we are going to find the volume of the embankment. So here volume of the embankment, again you just look at this diagram. So this is well, okay, this is the circumference of the well and this is the circumference of your embankment. Now we have to find the radius of the embankment. So obviously this is the radius, right? The radius is nothing but it is the line which connects the center to a point on the circumference. So this is the radius of the embankment. So how to calculate the radius? We know the radius of the well. Okay, radius of the well is 3 by 2. And the width is given as 4 meter. So when you add this 3 by 2 with 4, we will be getting the radius of the embankment. So 3 by 2 plus 4. Again when you take LCM, 4 2s are 8. So 3 plus 8 by 2, which is nothing but 11 by 2 meter. So this is your radius of the embankment. Right. So while writing formula for volume of the embankment, again when you look carefully, we need only the volume of the embankment here. But what is here? Here in addition we have the well, okay, we have the volume of the well, that is we have another circle inside. So While writing the formula, you see we need only this volume. So here the formula becomes pi r square h, right? The general formula is pi r square h. This is the formula for the volume of the cylinder. Since here we are confined with the another radius, right? Here we are writing it as r2 square minus r1 square. Right. So here again, am I making sense here? Because this volume of the embankment, it has an inner circle. So now we are removing that one because I need only the volume of the embankment, right? Therefore, pi in the place of r square, r2 square, okay, this is your r2 and this is your r1. So r2 square minus r1 square into h2. So what is the value of r2? It is 11 by 2 and r1 is 3 by 2. Again, just substitute the values and finally here we are ending up with the answer as pi 28h2. Right. So here the calculations are simple, right? 11 square, it is 121. If you know directly, you can directly write it as 121 and 3 square is 9 and 2 square is 4. Since the denominator is common, I can write it as 121 minus 9 which gives 112. So when you solve, finally here the answer is pi 28h2. So name this as equation number 2. So as I already said, volume of the well is equal to volume of the embankment. So volume of the well is 63 pi by 2 and volume of embankment is 28 pi h2. So pi and pi cancel each other. As I need h2, I am moving this 28 to the left hand side. So there it occupies the denominator part. So again, when you multiply, 2 times of 28 is 56 and 63 divided by 56 is 1.125. Right. So here I had made the division. Again, it is pretty simple, right? So finally, the height of the embankment is h2, which is equal to 1.125 meter. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.